Hello guys, my name is Lazaro and today we're going to be doing an easy LeetCode problem. This problem is called maximum depth of a binary tree. Given the root of a binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So basically, let's look at this first example, and we can only look at the first one because other examples don't show a diagram. But here we have 3, 9, 20, 15, 7. The maximum depth of this is 3. The reason we have that is because this 3 is on a depth level of 1. The 9 and 20 is on a depth level of 2. And then the 15 and 7 is at a depth level of 3. So the maximum depth is 3. So now that we read the problem, let's check the intuition or the logic behind how we would solve this. All right, so the first example, they give us a pretty shallow or easy tree. We have the 3, 9, 20, then we have the 15 and the 7. So just by looking at it, we know we want to get the depth, so we want to know how deep we're going. And since once we're on a current node, when we go to the left or we go to the right of the current node we're on, we know we're going a level deeper. So let's say this node we're looking at, the first node we look at, it starts with a depth of 1. When we move to the left or we move to the right, we're going to increment that depth by 1. Now our depth is 2. For our 9, there is no left or right node, so that one stops at 2, but the 20 could go deeper. The 20 still has a left and right node, so we can visit those left and right nodes and increment the depth by 1 once again. So now the 15 has a depth of 3, and so does the 7. Now with this, all we really have to do is just keep track of the largest number in a variable. There's multiple ways of solving this question. You can use a depth first search approach or a breadth first search approach. Depth first search is easy, way easier than breadth first search. Most likely not going to use it for this question, but a DFS does make the most sense. Now, what does depth first search mean? Well, it basically means that when we're on a node, we want to go as deep as possible first. So for example, if we're on 3 and we want to go as deep as possible, and we're starting with the left node, we're going to go to 9 and we're trying to go further down from 9. But since 9 has no child nodes, it stops there. So this is our order. First we check left and then we check right. We finish with the left and now we go to the right, which is 20. At 20, now we check left, because remember that's our order: left first, right second. So at 20 we do exactly what we did at 3. We check the left. Now we're at 15. Can we go any further? We cannot. So now, since we finished with the left, let's go with the right. And now we're at 7. Can we go any further? We cannot. So we're done with that. And this is what depth first search is. You can use depth first search with a stack or recursion. And I know this is extremely tilted. Let me just rewrite that. Oops, keep on touching the wrong button. A stack or recursion. There we go. Now for this problem, I'm going to be using recursion, but I do have other submissions where I can show at the end how you can solve this question using a stack. Awesome. So now that we know the logic, now that we know that we have to use depth first search, go as deep as possible, and every time we go deeper, increment the depth value by 1. So this would be 1 here, then this would be turned to 2, and then this 15 and 7 would both be 3. And then we have some outside variable that's going to keep track of the largest depth we've seen, which in this case is would be 3. So this is the intuition of the problem. Now let's actually see how the code would look like. Okay. So we want to create a function that does that depth first search or does that logic for depth first search. So let's create a function right up here. Call it depth first search. It's going to take a node and it's going to take a depth or a level. What this is going to do is, if the node is not none, the reason we want this is because we are checking this 15, or let's look at this 7 actually. Its left node is going to be none, and its right node is going to be none as well. It could be none or null, whichever, but it's not going to exist. So we only want to do this logic or take care of this counting and depth first search and trying to go deeper if the node actually exists. So if the node does exist, let's get its left value. So left is going to equal to depth first search with the node to the left of the current node we're on, and since it's to the left and it's going to be 1 deeper, let's increment depth by 1. And now we're going to do the exact same thing for the right. The only difference being, instead of visiting the left child of the current node, we're going to visit the right child. We will still increment the depth value by 1 though, because we are still going deeper. Now in this function, let's return the one we want to return is the depth, but we want the largest depth. So the best way of doing this is just creating a max and finding the max between left and right. Now, let's say it's not a node. How will we find the max? Well, we find the max when we're at the end, when we're at a leaf node. A leaf is a node that has no children. So 7, 15, and 9 are leaf nodes. When we're at the leaf node, we know that we've gone as deep as possible in this direction. We cannot go any deeper. So when we cannot go any deeper, let's return our level. Let's return the level that we stopped going deeper at. So with that, since we try to go deeper here, and there is no existing node, instead of actually touching that node, let's just return. Let's return that depth we're at. Now, to answer our question or to finish this problem, what we want to return, since this function is going to return the max depth outside of it to solve our question, let's just return whatever this function gives us. So right here, I'm calling the function with the root node that the problem passes to us and with 0. The reason I'm doing it with 0 is because I'm incrementing I'm incrementing it here every time I call left and right. If I were to change that 0 to a 1, then the else I will have to do -1. So I'm just going to leave it as 0. And this is all the logic we need. This is recursive, which because inside this function, the function it's calling itself. And it's calling itself with the left child of the current node and the right child of the current node. So it's going to do exactly what we talked up here. It's going to go to the left, and then it's going to go to the left again, but there's nothing there. So it returns true. It returns to the number 2. And then it's going to go to the right, and there's nothing there, so it returns 2. Because the reason we return 2 is because it's hitting that else block we created right here. Then after it finishes doing the left, it's going to try to do the right. And then on the right, it can go to the left again. And then it's going to do left and right. There's going to be none here. There's no nodes there, so it's going to return 3. Then after it finishes the left, it's going to do the right, then left, right, none in both. So it's going to return 3. And since we will only keep the maximum depth, the correct answer is going to be 3. Or it's going to return 3. And that's all the logic or all the code we need to solve this question. So let's actually write it out. So right here, I'm writing in Python. It should be easy enough to transfer it because you guys do have the pseudocode right there on the left. So let's create this function where it's going to take a node and a depth level. Then if the node does exist, if the node is not none, then left, let's call and check left with the left child of the node, and let's increment our depth. And let's also call this do the exact same thing with the right child of the current node, and let's also increment the depth. What we want to return is the max between the left and the right, the max depth. And the left and the right is going to hold, the value it's going to have is whatever this else gives it. Since it's just going to return the depth, it's going to return, left is going to be equal to the depth of the left subtree, and then right is going to hold the depth of the right subtree. Now, to solve this question, let's just call that function with the root node, and let's pass 0 as the depth. Now let's run this code, see if it works. It does. Now let's submit it. And it works, perfect. Now, let me show you how you can do this with a stack. So right here, I wrote a small little sentence or two right here. But this is how you can create a stack. Depth first search is, you could do it with a stack because you're looking at this value and then you're putting it on top of it, this one, and then you're putting on top of this one, and then the 20, the left and it's right. Then you're popping the 9, or sorry, you're popping the 20, and then you're putting the 15 and 7 above it. So the 20 is popped, 3 is done for, and then since the 7 is on top of it, you check that, and then you check the 15 and the 9 as well. Now that was a really brief explanation, but I can't go over stack in this video, but I do highly recommend you guys look into it. Look into a stack for depth first search, recursion for depth first search, and then, although we didn't use it for this problem, in breadth first search, a queue is used. So look into that as well. So this is the code for a stack. Like I said, we're popping it, but we still had the node and the depth. And then we're appending its left and right and incrementing the depth. So pretty similar to the recursion. Not totally too sure if I might have a breadth first search approach here. Let me check real quick, don't want to take too long. No. Let me check this one. No. So I guess it makes sense because a stack and using depth first search for the stack of recursion is much easier for this problem, but it's still um, totally doable to use a queue to solve this question. All right, so if you guys enjoyed this video, and you're interested, then I highly recommend you join our Discord server, which will be linked down below. We send questions for beginner and advanced programmers. This happens to be one of our beginner questions, but we send out these questions every single day just to help you practice and get better and hopefully land an interview or an internship or a job even. So other than that, I hope you guys enjoyed and thank you for watching.